I want you to imagine a scenario for a second. Just imagine a panicked employee submits an urgent IT ticket, right? And it reads, "The Wi-Fi router in the conference room smells like burning plastic and is physically smoking."
Oh, wow. Yeah, that is not a good day for the IT team.
No,
Yeah.
definitely not. But think about it. A traditional AI ticket router might just scan that text, zero in on the word Wi-Fi, and confidently assign the ticket to the network software team.
Right, doing that while a literal fire is starting on the third floor.
Exactly. We've all seen those AI tools that are, perfectly happy to give you a completely wrong, disastrous answer with absolute unwavering confidence.
Yeah, because traditional machine learning systems are notoriously overconfident.
Yeah.
I mean, they don't know what they don't know. They are designed to force a prediction, even when the underlying data doesn't make any sense to them at all.
Right. But what if an AI was actually smart enough to recognize its own ignorance? Like, what if it could read that smoking router ticket, pause the workflow, and just say, you know what, I'm completely confused here. I need a human to look at this.
That is a profound shift in how we approach enterprise technology. We're so used to the black box that just spits out a guess. But what you were describing is a system built on intellectual humility.
Intellectual humility, I like that.
Yeah, and that changes the entire dynamic between the human worker and the machine.
Okay, so let's unpack this because this is exactly what we are diving into today. Our mission for this deep dive is to explore a platform called HumAIne.
Right, which stands for Human in the Loop Active Learning.
Exactly. And this is a system specifically designed for IT support and ticket routing. The goal today for you listening is to really understand how this platform blends, human intuition with machine learning to create a workflow that is smarter, safer, and just incredibly transparent.
And just to set the stage, HumAIne is essentially tackling the massive bottleneck of IT support by combining three core capabilities.
Okay, what's the first one?
First, automated ticket classification, basically getting the problem to the right desk. Second is interactive model training with human feedback. That's the raising its hand part you mentioned earlier.
Right, the system admitting it needs help.
Exactly. And third is automated resolution generation, where it actually helps the human draft the solution.
Which is huge. But to understand what makes HumAIne so special, we really have to look at the AL in its name, active learning. Because I think a lot of us have a mental model of how AI is trained, and honestly, the way most people think AI learns is just pure brute force.
Yeah, what I like to call the dump truck method.
The dump truck method.
Yeah, if we connect this to the bigger picture of traditional machine learning, the old school approach is incredibly tedious. You take thousands, maybe hundreds of thousands of past IT tickets.
Wow, that's a lot of data.
It is. And you have human engineers painstakingly label every single one of them manually. Like password reset goes to IT, blank screen goes to hardware. Then you just dump all that labeled data into an algorithm, hit train, and cross your fingers that it's figured out the patterns.
Which sounds incredibly inefficient. I mean, you're wasting valuable human brain power labeling endless, obvious tickets.
It is a massive drain on resources. Active learning flips this entirely. In HumAIne, the system uses standard, highly reliable mathematical models. We are talking about models like logistic regression, random forest, and support vector machines, or SVMs.
Wait, let me stop you right there. Why those specific models? I mean, why not use one of those massive multi-billion parameter neural networks we hear about in the news every day?
That's a great question, actually. It really comes down to speed, efficiency, and most importantly, interpretability.
Interpretability.
Yeah. Massive neural networks require huge amounts of computational power, and they act like opaque black boxes.
Yeah.
Logistic regression and SVMs are incredibly fast. They are mathematically precise at drawing boundaries between different categories like hardware versus software.
Oh, I see.
And they allow us to easily look under the hood to see exactly how they arrived at a decision. So they're perfectly suited for classifying text data quickly in an active learning loop.
Okay, so we have these fast, efficient models. Walk us through the actual workflow. How does the active learning part actually kick in when a bunch of new unlabeled tickets hit the system?
So instead of asking a human to look at all the new tickets, the model evaluates the entire unlabeled pool on its own first. It calculates a mathematical certainty for every single ticket.
Okay.
Then it isolates only the tickets it is unsure about. It takes those confusing edge case scenarios and sends only those to a human expert through the user interface.
Got it.
The human looks at the complex ticket, provides the correct label, and then the model immediately retrains itself on that specific new piece of data.
So imagine a teacher giving a student a stack of 1,000 flashcards to study. In the traditional dump truck method, the student just stares at all 1,000 cards sequentially.
Right, exactly. Wasting time on things they already know.
Right. But with active learning, the student actively sorts through the deck, pulls out the 10 hardest cards, the ones they've literally never seen before, and brings just those 10 cards to the teacher's desk for an explanation.
That is a perfect analogy. The human IT expert isn't wasting their day explaining 2 plus 2. They're only deploying their highly specialized human intuition on the actual complex problems.
The machine handles the mundane, and the human handles the anomalies.
Precisely.
Okay, I buy the flashcard analogy, but I'm kind of stuck on the mechanics here. I mean, a human student feels confused, but an AI is just math. How does a mathematical algorithm actually experience confusion? Like, how does a computer know what is hard?
What's fascinating here is that HumAIne actually has several distinct ways to define confusion mathematically. These are called query strategies.
Query strategies.
Yeah, they are the specific logic algorithms used to isolate the hardest tickets.
Let's explore those, because I really want to know what AI confusion looks like. What's the most basic way it flags a ticket?
The most direct strategy is called uncertainty sampling, and specifically focusing on something called least confidence.
Least confidence. Sounds pretty self-explanatory, but how does it work?
When the model looks at a ticket, it generates a probability percentage for every possible IT team. If its absolute best guess, its highest probability is still mathematically very low, it triggers a flag.
Okay, so it might look at a ticket and calculate, my top guess is the database team, but I'm only 15% sure.
Exactly. That's a low confidence score, so it asks for help.
Okay, that makes sense. It's basically admitting it's guessing in the dark, but what if it's not in the dark? What if the AI is actually highly confident, but the ticket is just incredibly deceptive?
That brings us to another flavor of uncertainty sampling called margin sampling. This strategy doesn't just look at the top guess, it looks at the difference, the margin, between the number 1 guess and the number 2 guess.
Oh, I see. Let's go back to that burning router ticket from the intro. It sees Wi-Fi, so it's maybe 49% confident it belongs to the network team, but it sees burning and smoking, so it's 51% confident it belongs to the hardware team.
Precisely. Its overall confidence might be relatively high for those 2 specific teams, but the margin between them is razor thin. It is a mathematical dead heat.
So margin sampling catches that.
Right. It is designed to catch those precise tug-of-war scenarios so the human can step in and break the tie.
Okay, so we have a tie between 2 teams. What happens if the ticket is just total chaos, and the model thinks it could equally belong to 5 different teams?
Then you would use the entropy strategy. In information theory, entropy measures unpredictability or noise. If a ticket causes the model's probability scores to scatter evenly across the network team, the database team, the software team, and the security team, the entropy score spikes.
So it flags the ticket because the data is causing systemic chaos.
Exactly. But here's where it gets really interesting. We've talked about least confidence, margin sampling, and entropy. All of those involve a single model getting confused.
Right.
What if we use multiple models? Because there's a strategy called query by committee.
Query by committee. That sounds like an ensemble method.
It is. Query by committee is an ensemble disagreement method. In machine learning, an ensemble means you have multiple different algorithms, a committee evaluating the exact same ticket.
So imagine a boardroom full of little AI executives looking at the same file. But wait, if they're all just copies of the same algorithm, won't they all just agree with each other anyway?
They would if they were exact copies. But to build a proper committee, you deliberately train each AI executive on a slightly different subset of your historical tickets. So one model might be a specialist in older network issues, while another was trained heavily on recent software bugs. They develop slightly different worldviews.
Got it. So you feed the new ticket into the boardroom. If they all look at their different past experiences and reach the same conclusion, yes, this is a software bug, you have high certainty.
Right.
But if the network specialist vehemently disagrees with the software specialist, the system recognizes the conflict.
Exactly. It recognizes that the ticket is contentious. So it escalates the disagreement to a management, the human user, to settle the debate. And I should mention, HumAIne also includes a random sampling strategy.
Random sampling. Why would you want random?
Well, you don't use it for efficiency, but you need it as a control group. It proves that your smart strategies, like the committee or margin sampling, are actually outperforming a random baseline.
Okay, so the boardroom algorithm has escalated a tough ticket to me, the human. What do I actually see on my screen? Because if I just get a blank box asking me to do the AI's job for it, I'm going to get pretty annoyed. It doesn't seem very helpful.
This is where we transition to the dispatch labeling page in the user interface. And this is where HumAIne shifts from just being an algorithm to being a collaborative workspace. It uses a framework called Explainable AI, or XAI.
Explainable AI. That's a massive buzzword right now. Everyone claims their AI is explainable. What does that practically look like for the human staring at the screen?
HumAIne implements a specific framework called LIME. That stands for Local Interpretable Model Agnostic Explanations.
Okay, Lime.
Yeah. When the system hands you the tough ticket, it doesn't just show you its best guess. LIME actually visualizes its thought process by highlighting the specific keywords in the ticket that mathematically pushed its prediction in a certain direction.
Wait, I have to push back a little here. Highlighting a keyword. If a frustrated employee writes a 3-paragraph rant about a broken monitor, highlighting the word screen doesn't mean the AI actually understands the context. How does Lime even know which word was important?
It's a very fair skepticism. LIME doesn't just look for buzzwords. It runs a rapid series of micro-experiments in the background. It uses a technique called perturbation.
Perturbation, like disturbing the data.
Exactly. LIME takes the user's ticket and starts temporarily deleting or turning off words one by one, feeding the altered text back into the model to see what happens.
Oh, wow.
Yeah. If LIME deletes the word timeout from a database ticket, and suddenly the model's confidence drops from 80% down to 20%, LIME knows mathematically that the word timeout carries massive weight for that specific prediction. So it highlights timeout in green for the human to see.
Okay, that is brilliant. It's basically reverse engineering its own guess by seeing what breaks the prediction.
Exactly. It shows you the mathematical importance of the features, and it takes it one step further. Right alongside the highlighted keywords, HumAIne displays a similar ticket.
A similar ticket.
Yeah, it searches its training data and says, not only did the word timeout influence me, but I made this guess because this current ticket looks extremely similar to this specific verified ticket from 3 months ago.
See, this is the paradigm shift. If an AI just blindly commands me to send a ticket to the database team, I won't trust it. I'll double-check its work, which entirely defeats the purpose of automation in the first place.
Right, because you're just redoing the work.
Exactly. But if it highlights the heavily weighted words based on perturbation and literally shows me an identical ticket from last Tuesday, suddenly I trust the system. It's showing its work.
Showing its work is the core philosophy here. Once you, the human partner, review that LIME explanation and lock in the correct team from the drop-down menu, the active learning feedback loop closes instantly.
It updates right then and there.
Yes. The system saves your label. It immediately retrains the underlying model, like that SVM or logistic regression we talked about with your new ground truth data. It updates its internal accuracy metrics and then fetches the next difficult ticket.
And what happens when the training is done? Do we lose all that amazing transparency when the system goes live in the real world?
Not at all. HumAIne has a dedicated inference page for real-world deployment. When brand new tickets start flooding in from employees, the system automatically routes them.
Okay.
But it continues to generate those LIME explanations and surface those similar historical tickets for the IT staff receiving them. The transparency is a permanent part of the daily workflow.
Okay, so we've successfully routed the ticket. The active learning worked, the system explained its math, and the ticket is sitting in the correct inbox.
Right.
But routing a ticket is only half the battle. We've basically just acted as a highly intelligent traffic cop. Someone still has to actually solve the poor employee's problem.
Which brings us to the second half of HumAIne, the ticket resolution feature. Routing is about classification, but resolution is about generation. And to do this, HumAIne leverages a technology called Retrieval Augmented Generation, or RE, pronounced exactly like a piece of cloth.
Okay, so RAG. So instead of classifying, we are now generating text to reply to the user. But wait, generating text with large language models is exactly where we see those massive AI hallucinations.
Yes, the hallucinations are a huge risk.
Right, like if an AI hallucinates and tells an employee to delete their System32 folder to fix a printer glitch, that's an enterprise disaster. How can we trust it to write solutions?
This raises an important question. And it's precisely why HumAIne uses RAG instead of just plugging into a raw, unfiltered LLM. RAG is designed to anchor the artificial intelligence to your company's actual reality. Let's walk through the pipeline step by step.
Okay, let's do it. I'm an IT worker. I have a routed ticket in front of me. I open the ticket resolution page. What happens?
The moment you input the ticket's category, title, and description, the RAG pipeline kicks off. Step 1 is retrieval. The system dives into your company's internal knowledge base to retrieve the most similar historical tickets.
How is it searching, though? Is it just doing a basic keyword search for the word printer? Because we know that's highly inaccurate.
No, it uses a much more sophisticated method called vector embeddings.
Embeddings. Let's define that because it sounds incredibly abstract.
Sure. Imagine a massive, multidimensional map of space. Every single past IT ticket in your company's history is translated into a string of numbers, a vector, and plotted as a star on this map.
Okay, I can picture that.
Tickets with similar conceptual meanings are clustered closely together into galaxies. So a ticket that says cannot connect to server and a ticket that says network drive unavailable might not share exact keywords, but conceptually they are placed right next to each other in this mathematical space.
So the system maps the new ticket, finds its exact coordinates in space, and grabs the historical tickets clustered right around it.
Exactly. That's the retrieval. Step 2, it doesn't just find those old tickets, it retrieves the actual verified resolutions, the written solutions that successfully fix those past issues.
Oh, wow. It's pulling the actual historical fixes.
Right. Then comes step 3, the generation. It takes the user's current problem and indeed those successful past resolutions, and it feeds all of that hyper-specific context to a GPT large language model.
Yeah.
It instructs the LLM do not guess, synthesize these specific past solutions to generate a custom response for this new user.
So it drastically reduces hallucinations because the AI isn't riffing based on what it read on Reddit 3 years ago. It's grounded in your company's verified history. It's saying, here is how WE solved this problem here.
Exactly.
But even with that grounding, I assume we still have our human in the loop.
Always. The user interface doesn't just blindly email this generated response to the employee. It displays the AI's suggested reply on your screen. But right next to it, it displays the top 3 similar past tickets it retrieved from the vector space, along with their actual resolutions and their mathematical similarity scores.
Oh, wow. It's showing its work again. So if I'm the IT worker, I can read the AI's suggested draft, glance to the right, and verify exactly which past tickets it used to write that draft.
Exactly. You act as the editor. You evaluate the response, maybe tweak it to add a personal touch or updated detail, and then you send it. And here is where the system ensures its own longevity. Through its API capabilities, HumAIne constantly processes this human feedback. You can trigger the system to rebuild its embeddings.
Rebuild the embeddings. So redrawing that mathematical star map you mentioned earlier.
Exactly. As your company adopts new software, changes policies, or encounters completely novel bugs, your human workers are editing these AI responses and submitting new solutions. By rebuilding the embeddings, the RG system ingests all that new knowledge.
That's amazing.
It literally updates its internal map of your company, ensuring that tomorrow's AI-generated response incorporates the new solutions you taught it today.
It's a living system. So
Right.
what does this all mean? When we look at everything we've unpacked today, from the active learning and those complex query strategies, to Lime visualizing the math through perturbation, right down to the RAG pipeline generating grounded solutions, it paints a really clear picture.
It really does.
HumAIne isn't a black box trying to replace human IT workers. It's a deeply collaborative tool. It respects the human's time by using active learning to only escalate the genuinely confusing edge cases. It respects the human's intelligence by explaining its reasoning, and it assists in the heavy lifting of drafting replies. It puts the human precisely where the human is needed most.
It shifts the human from being a basic data processor to being a true supervisor, editor, and teacher of the system. The human leverages their complex judgment, and the machine leverages its massive scale.
Which leaves us with a pretty profound final thought. If systems like HumAIne are fundamentally designed to constantly seek out the boundaries of human knowledge, using those query strategies to escalate only the most confusing, unprecedented, highly volatile tickets to us, what happens to the workflow when the issues become so incredibly complex that even the human experts can't agree on the answer?
That's a great point.
Right. When the mathematical algorithm points to a ticket and says, I don't know, and the human engineer looks at it and says, well, I don't know either, who acts as the teacher, when both the human and the machine are completely stumped?
That is the frontier of enterprise IT. And it's a question every organization leaning into this technology will eventually have to answer.
Something for you to mull over until next time. Keep exploring, keep questioning, and we'll catch you on the next deep dive.